We are a team at Nanyang Technological University, Singapore. We work on the decipherment of linear array. We work on linear array in general, but of course, now the decipherment is, I mean, it's what it should be done, and it's difficult, almost impossible. In any case, it's from 1999. I work on linear array. I have tried everything, and at a certain point, we decided to try to apply a computational approach to try to apply a brute force attack, a cryptanalytic brute force attack to linear array. And so we needed Colin, we needed engineer, is a programmer, and we needed to write a program in order to apply our strategy. So before we thought about our strategy, and then we thought about the program. Now I leave the space to Colin because he will explain both the strategy and program. Better if he explains the program and a little bit of the strategy, a little bit less the strategy, because the strategy is still ongoing. So I hope that Colin is ready. I don't see him, but I'm pretty sure he is ready. Thank you.
Thank you, Dr. Francesco. So do let me share my slides with you all. So this will be my presentation. Okay, so let me start off with dear all. I'm Colin, and together with my supervisor, Dr. Francesco Perono, I'll be making a presentation on cryptic analysis and language deciphering on a brute force attack on an undeciphered writing system. So this will be the outline of my presentation. So to start off, I will begin with an introduction on linear A as an ancient writing system, followed by how Python has been regarded as a powerful programming language. And next, I will continue with an overview of the linear A decipherment Python program, together with the visual representation of how the Python program should work. And to end off, it will be my list of references as well as my acknowledgement. So to start off, linear A is one of the writing systems of the Ancient Aegean Minoan civilization of Crete, dating back to the Bronze Age. Despite many past attempts by scholars, glyph breakers, and linguists, linear A continues to remain undeciphered because of its elusive underlying language. So linear A has around 90 signs and symbols which are currently in regular use, where a large majority of them are considered distinct or unique when compared to linear B. Linear A symbols and inscriptions can be found on a wide variety of artifacts that would include roundels, tablets, and seals that will indicate economic transactions. Okay, over here on the left, we have the linear A tablet ARKH2 that has been digitally enhanced. Whereas on the right, we have the linear A tablet KH5 also digitally enhanced. So from the look of these two tablets, we can identify that there are many linear A symbols and signs present on just one tablet alone. So moving on, this is the linear B syllabary. Linear B was deciphered by Michael Ventris in 1952. Linear B was used to encode Mycenaean Greek, and it consists of about 87 syllabic signs. So And throughout numerous decades, past attempts of deciphering linear A would involve assigning linear B phonetic values to linear A signs that appear graphically similar. However, by just assigning linear B phonetic values to linear A signs alone has caused many to raise questions on the reliability of this decipherment approach. Such arguments are then supported by these factors. So, okay, firstly, linear B encodes Mycelium Greek, whereas linear A encodes Aegean Minoan. Okay. Next, there is a disproportionate time difference between the use of each writing system. Furthermore, close to 80% of linear A symbols are considered to be unique or distinct when compared to the linear B. And with that, recent studies on the decipherment on linear A has proposed that linear A could have relations with other languages such as Luwian and Hittite, and also various language families such as the Semitic language family, the Indo-European language family, and even the Afro-Asiatic language family. So, with the assistance of a software developed using the Python programming language, our aim is to identify and isolate significant clusters of linear A symbols while attempting to reconstruct the Minoan phonetics. Okay, so Python has been regarded as one of the most popular programming language in the world. This is because Python can serve as cross-compilers to other programming languages such as JavaScript, while also having other and various implementations. This includes data analytics, creation of computer graphical user interface, as well as web application design by using the Python modules, pandas, PyQt, as well as Flask. With that, our research team has adopted pandas and PyQt to be the two main Python modules that will be used for our Python program. Okay, so to start off, the Python program can be segmented into two portions, namely the specific decipherment as well as the general decipherment. Okay, so for the specific decipherment portion, we incorporated the comparisons of various language dictionaries with our linear A master list that is comprised of Derived, Volume 1, 2, 5, inclusive. Next, the basis of comparisons would be the identical matches between the linear A strings and the words in the dictionaries after having the vowels removed. So the results will then be displayed in a clear table format with 4 columns, namely which are titled identical matches, which would indicate the strings with a 1-to-1 character match, followed by the linear A word, which will indicate the original linear A word without any modifications. Next will be the source, which will indicate the tablet source, where the original linear A word can be found. And lastly would be the dictionary word, which will indicate the original word from the dictionary of interest. Okay. So moving on. All right, so the picture on the left shows you that our specific decipherment front page. This front page will indicate the comparisons of various dictionaries of languages with linear A, such as Anatolia, Hittite, Luwian, and even Hebrew-Semitic. Okay, so on the right, we have the results displayed in the table format as per mentioned. All right, so moving on. Okay, in addition to that, for the specific decipherment portion, we have also included the analysis of triplets present in linear A words. Symbols in linear A that do not appear graphically similar to any of the symbols present in the linear B syllabary would be represented as numbers in the form of a triplet or 3 digits. So allowing a triplet to take on any possible character ranging from A to Z, we would then make comparisons with the words in the other dictionaries and analyze the frequency of which a character replacing the triplet would have identical matches. By allowing such form of analysis, we can then provide reasonable justification of replacing the triplets with the character of the highest frequency, and thus allowing us to have a better understanding on the Minoan phonetics. So, okay. So this will be the visual of how the triplet analysis should look like. To interpret these results, we can see that on row 6, the triplets of 188 have one match with character D, whereas on row 7, we notice that the triplet of 076 have 2 matches with character B. Okay, so moving on. For the general decipherment section, we have developed 2 functions, namely the general decipherment and also a modified version called general decipherment 2 for short. So under the first general decipherment function, users can input any spreadsheet files available into their program. So by using the pandas Python module, the program will carry out a similar comparisons with the word present in the file. Similarly, the results generated through this function are also displayed in a clear table format made up of the same 4 columns, identical matches, linear A word, source, and also file word. So with that, users are also able to download the results stored in a CSV file locally into their computers. Over here is a visual representation on the requirements for the upload file. Okay, so the data inside the spreadsheet file should only be restricted to only 1 column. Okay, and moving on. Okay, so on the left, it shows us our general decipherment page where there is a button titled Upload Sheet. So upon clicking the button, users are able to upload the spreadsheet of their choice. And on the right, it shows us the results that will be displayed after clicking on the upload sheet button and uploading a proper sheet that is of the requirements. So moving on. Okay. So over here, for the general decipherment 2 function, a modified version of the previous function, users are able to make dynamic changes in their comparisons. Users can make comparisons based on their two files of choice, namely the base sheet as well as the comparison sheet. Similar to the earlier function, this function would output the results in the same format, and users are able to download the results in their computer as a CSV file. Through this general decipherment 2 function, users would have a higher degree of freedom, and as it enables more efficient work, as changes can be made to both their comparison sheet as well as their master list dynamically. Okay, so moving on. Okay. So this is a visual representation of how the requirements should be for the base sheet as well as the second sheet. All right. So for the base sheet, the data should only be restricted to 3 columns only. And these 3 columns are titled as source, new format, as well as linear A. Whereas on the right, it shows us the requirements needed for the second sheet. Data for the second sheet should only be restricted to just 1 column alone. Right? Okay. So over here, on the left, we have the visual representation of the general decipherment 2 function. We notice that there are 2 buttons labeled upload base sheet as well as upload second sheet for users to upload their base sheet and their comparison sheet respectively. Whereas on the right, we have the results upon uploading the necessary spreadsheet file into the program. Results will also be displayed in the table with the 4 columns as mentioned. Okay. So regarding the ergonomics of the program has been designed to be an executable GUI file, or for short, graphical user interface file, into the computer using the Python module pyqt, as you can see from the figure above. And with that, users of this program need not have Python installed into their computers. Instead, they can use the shortcut created and have direct access to the program. Okay. So in conclusion, the linear, by allowing a indiscriminate comparisons of the words of choice through the use of the Python program, it allows us to provide a large-scale brute force attack on the linear A corpus. Decipherment of linear A will now involve a more rigorous and statistical approach, as we will look to isolate and analyze clusters of linear A words in an attempt to have a better understanding of the linear A symbols and signs. And with that, This will be my list of references. And to end it all, we wish to acknowledge the funding support for this project from the Nanyang Technological University under the Undergraduate Research Experience on Campus program. And thank you.
Thank you very much. I have a question by Anna Judson.
Hi, thank you. I have some methodological questions, not about the computing part of your project, but about the original input, particularly relating to how you're inputting linear A. You referred to being skeptical about previous assumptions that many linear A signs have similar sound values to linear B, but I'm not sure in that case what basis you are using for comparison with other languages. I'm also not sure what you're proposing as data sets for comparison. Your list of languages that you were comparing it to included things with quite different statuses, like Hittite versus Proto-Celtic. Obviously one of those is reconstructed. Linear B sounds can of course represent a very large range of sound values in some cases, even before we try and reconstruct back to what value or values similar signs might have had in linear A. So again, how do you deal with that, and how does a sort of a brute force statistical approach deal with the fact that the linear A corpus is just so small that we have very little evidence to go on a lot of the time in trying to find patterns and see the significance of them?
Yeah, maybe I can answer. Thank you. This is the basic question. So how do we deal? We deal badly, in the meaning that it's a trial and error. There is not. I know maybe it's not methodologically perfect, but it's trial and error. So we have a strategy, especially to compare our possible linear A transcriptions with Semitic and Afroasiatic languages. And maybe I cannot show or explain the whole strategy because it is too long and is still ongoing. But you're right, how to read linear A. If we were able to read linear A will be possibly deciphered. So yeah, we have a hybrid approach. We use the linear B sounds, the linear B phonemes, if we can call them this way, and we try to find possible matches. Before we were doing that manually, and it was almost impossible. It was too long. Now we are doing that with this program. So you have to imagine us working in a purely empirical way. So this is more or less the point. So you are right. I mean, it's impossible to say, okay, this is the standard transcription of linear A, because if we had the standard transcription of linear A, we would be able to read the linear A. And so we are just trying to make comparisons according to a sort of trial and error strategy. I can tell you that so far, despite it was not my original idea, and it was not my original hope also, we are being able to isolate the clusters, and these clusters are the clusters connected mainly with ancient Egyptian, and it was quite unbelievable to me. The point is that this approach doesn't allow yet to read the tablets, and so it's just statistics, if we want to call it this way. But yeah, the point is exactly that. How do? We try. It's a sort of continuous attempt. And you can see I have lost some parts of the talk by Colin because my net was going. We are still in lockdown here, so we are from home, not from our offices. But you can see that we are comparing also with languages that have no possible contacts or connections with linear A. We are making experimental comparisons with Basque, for example. So it's a trial and error. I don't know if I have answered your question.
I'm not very clear on how a trial and error method like you described would have sort of contextual controls on the results, but I don't want to take over from other people asking questions. So thank you.
Thank you. And a question by Kevin Donnelly.
I think it's a really interesting idea because it allows you to look at things that you probably wouldn't have time for in the real world. You just jump straight at it. Do you have the code somewhere in a Git repo, or is it available anywhere?
Yeah, your question. Yeah, Colin can answer. Yeah, thank you.
We will be intending to put put a link on the program into our website on our NTU website, Nanyang Technological University website. So I think from there it can be distributed locally just from the download of the link.
Okay, great, thanks.
Yeah, in theoretical, sorry if I made the program allows this kind of comparisons. So we use it for linear array, but in theoretical you can use it for everything. We have a sort of we are preparing a sort of corpus for linear array with reproductions by hand. And so yeah, like Colin told, we think to attach the program to that website.
Great. Yeah, thanks very much.
Thanks.
And a question by Daniel Harbour.
Hi, really fascinating work. What have you done? Have you got a proof of? Do you know what because you need to know what an answer looks like, what a successful answer looks like. So you can say, oh, look, we've reached a level of certainty with ancient Egyptian that we would have had with ancient Greek for linear B. Yeah,
we definitely should do that. The fact is that I had not yet the time and not enough manpower, but yeah, I was thinking about that.
Okay.
So yeah, I mean, thank you, because this will be quite good, especially to start to make a comparisons and to have already a sort of repeated result. Yeah.
How new is this work?
Sorry, I have my cat on my desk. I apologize, but my wife has escaped and the cat is jumping on the desk. Sorry.
How old is this work? How long have you been doing it?
We have started, I mean, it's a lot of time that I work on linear array, but this computational approach, we started around 2 years ago. Okay. 2 years ago, because we got a research grant, and it's very rare in Singapore that they give you a research grant on linear array. And so we have been able to hire some research assistants and to start to make the work in a systematic way. But before calling, we had another engineer. We had different ideas to develop the program. And so we had some delays because Colin had to rewrite completely the program. So it's 2 years. The computational component, 2 years around.
Mm-hmm. And how much longer are you going?
I have time. I mean, officially and formally, I have time till August 2021. But now it's the first time. I mean, they are the first weeks. Unfortunately, there is the COVID situation and all these context, but they are the first weeks that we have the program complete. So our team members, our research assistants are starting to make the comparisons. But at the moment, the comparison, like I told you, they are trial and error. We are trying to see if we find some possible tracks and follow these tracks without making a whole comparison, because we need to test the program.
Great, thanks.
Thank you, thank you.
A question by Natalia Elvira.
Yes.
Thank you. So I'm going to make the opposite question to Dan, actually. So if this is a matter of trial and error, how can we measure the error and where it has failed? So, for example, how can we measure from the results whether the interpretation of some signs might be should be revised perhaps or not?
Yeah, this is another very good question. Again, the point is, the dream or the ideal result should be to have enough clusters or enough matches to be able to give a sort of possible reading of the linear array documents. And that will be the point. The problem is that so far we had not yet time to develop these. And if I have to give a direction, and probably is wrong, is towards ancient Egyptian, because most of the possible but really hypothetical matches we have found through our comparisons now are from ancient Egyptian. So the point is that we will never 100% right results with the program. The program can give us a direction, can tell us, okay, out of, I don't know, 100,000 attempts, we have identified these possible clusters. Are these clusters located in significant points in the tablets? Are they allowing us to read them or to try to give an interpretation of them, and so on and so forth? So the program in practice is to allow us to work on all kinds of hypotheses. And I repeat, we are also trying to do that sort of absurd way, testing Celtic, Basque, so languages that are, of course, not connected with linear A. But we are trying to do that in order to see also the percentage of possible mistaken results. So this is the point, again, if I have been able to answer your question.
Thank you very much, Francesco.